Hey ladies, so today we are doing section 7.2, and what we're going to be looking at, we're finally getting there, is transformations of exponential functions. So mentioned that quite a few times in the last videos, so hopefully you guys had some time to prepare for this. So basically what we're going to be looking at is stretches, whether they're vertical or horizontal, and we're also going to be looking at translations, whether we're moving up, left, right, or down. We'll look at how different values will affect our exponential function. So here we have a general form of our exponential function. We have y is equal to a times c, and that's our base there. And that's to the exponent, we'll have b times x minus h, and that whole thing there is adding with k. And just as a note, a, b, h, and k, so those are all new constants that we haven't seen before compared to our previous understanding of exponential functions. So that was y is equal to c of x. So those a, b, h, and k will change your graph in different ways, and we are going to look at them right now. So I'm just going to scroll down. So your first parameter, we have a, and that's that number that is multiplying with your base function right there. And so what that will do is it will create a vertical stretch about the x-axis, and that's by a factor of absolute a. If your a value is less than 0, what's going to happen is that you're going to have a reflection in the x-axis. So essentially, what's going to happen is it's going to be on the other side of your x-axis, where we saw all of our exponential functions in last section. They were all above your x-axis. So what's going to happen is if a is negative, then it's going to flip over that x-axis. And so it's kind of similar to your quadratic equations, or quadratic equations. You guys saw that if that x squared term was negative, your graph would be flipped upside down. So it kind of has a similar, a similar effect. Okay, and then so just one note here. Let's take example. What if we had the coordinate x, y in our original function? So if we're going to use this graph here, our original function here would be y is equal to 3 to the power of x. Say that is one of our original coordinates, x and y. If we were to apply the transformation, and so we'll use y is equal to 4 times 3 to the power of x. We'll use that example. If we were to apply that transformation where a is equal to 4, your x value here is going to stay the same, but your y value will change by a factor of 4. So you'll have 4y as your new coordinate. Okay. So here we can look at an example. We'll use a more specific example. Let's look at the y-intercept. So of our original function, that one is at 0 and 1. In our transformed function, with a is equal to 4, you multiply that y value by 4, and what you're going to end up with is 0 and 4. So if you guys can see how that a value there will change your function. So the x value stays the same, just your y value changed by a factor of 4. So then looking quickly, we can see here in this example, we have y is equal to negative 2 times 3 to the power of x. Here our a value there is negative 2. So here you can see that reflection across the x-axis. So what happens is that your value changed there from 1 to negative 2. So once again, you guys can see how that a value changes that y value. Okay? Moving on, now we'll look at b. So b will be a horizontal stretch about the y-axis by factor of 1 divided by the absolute value of b. So there's a kind of key little difference there. So we're not going to multiply it by b. It's going to be a factor of 1 divided by the absolute value of b. And also one note there is that if b is a negative number, if it's less than 0, then you're going to have a reflection in the y-axis. Okay? So here we can see again, if we had a coordinate of x and y, now what's happening is that we're changing our x value. So our y value stays the same, but we're going to divide that value by b. Oh, sorry, that x value by b. So let's look at an example here. So as you guys notice, our y-intercept stays the same, because remember, x is equal to 0 there. So 0 divided by any number is just 0. So in theory, that point should stay the same. Okay? So let's look at another example. So here we have, let's say, 2 and 4. This is in our original function. We have 2 and 4. Then we can look at, let's go with our one where we can actually see this. So here we have a b value is equal to 3. So what's going to happen is that you have that x value, divide that by that b value, so you'll have 3, and your y value stays the same. And if you guys look at that, it's roughly close. That's approximately 2/3, sure. So there's, but you guys can probably look at some different examples maybe, but try not to use ones where you obviously can't see it, but this example here should be hopefully good enough for you guys to see that your b value affects your x value in that way. Okay, so your next one is that we have k, and that will create a vertical translation, so we're moving either up or down. And so that one, if you guys look here, if we had our original coordinate of x and y, that's going to affect only your y value. So if it's up or down, remember that only changes your y values, and it's going to change it by the value k. So if it's positive or negative, if it's negative, it'll go down. If it's positive, it'll go up. And then one last thing, it'll also change is it'll change if we had a horizontal asymptote. It will also change that equation. Okay, so let's look at an example here. So our original function here, we have y is equal to 4x. Here we have a k value of positive 2. So if you guys notice, it went 2 units up. In the example below, we have 4 to the x minus 3. We have a k value is equal to negative 3. So if you guys watch, it goes down 3 units. Okay, and so that also does change that vertical asymptote. It moves it down 3 units as well. Okay, so if you guys actually even look here, we can once again consider the points. Here we're at 0 and 1. Then we're going to apply that transformation. So where we have a k value of positive 2. So that means that we have to go 1 plus 2, and our new value will be 0 and 3. If you guys look there, then that's exactly where that is. Okay? Alright, so last one there, guys. So here we have h, and h will cause the graph to shift either left or to the right. So it does a horizontal translation. So we're going to go back to our, our unique coordinates. We have x and y. So what's going to happen is that it's going to change your x value, but it will not change your y value. So if you have an h, if you had positive h, it'll be x plus h, and obviously you would subtract if it was a negative value. One thing that I do want to point out here, ladies, let's go up to this equation. Here we have x minus h. So what we're going to be given in our equations is the negative value, so we need to switch that sign. So here in this example here, let's look at, so we have y is equal to 6x, and in this going to the left, here we have 6 to the x plus 2. And here, our h value, remember it's x minus h, so your h value here is going to be negative 2. So I guess that's one thing we can note. If it's negative, it'll shift to the left. If it's positive, it'll shift to the right. You guys should know that from your previous units. It follows those same kind of principles or those same kind of rules that our previous units would have looked at. Okay, so if it's a negative, it'll shift left, which would make sense because here negative, it's going to be shifting left, so it's going to be getting smaller. If it's positive, it's going to be getting bigger. All right. So if you guys want to look at that example, let's look at let's keep going with our y-intercept. Here we have 0 and 1. If we want to look at this equation here, we have y is equal to 6x minus 3. It means your h value there is a positive 3. So it's moving to the right 3 units. So you can count there. So it goes 1, 2, and 3. So your new value becomes, oh, sorry, that should be 3 and 1. So it changes that x value. Okay? So now we're going to look at some examples. We're going to put all of this together. It's going to be wonderful. You guys will love it. All right. And I guess one note that I should also make here is that when you're applying those transformations, you must apply the parameters a and b first, then apply h and k. And that's if you guys choose to graph the original and then apply the parameters afterwards. But we'll see what that looks like in a bit. So let's move on to our examples. Okay, so here in this first one, we need to consider the exponential function. Here we have y is equal to 2 to the power of x. Then we're also given that they have some transformations. There's one where we have y is equal to 2 to the power of x minus 1, and y is equal to 2 to the x plus 1. So here we need to describe the corresponding transformations. then graph all of these functions along with their transformations on the paper that I gave you, or the nice little graph paper here that I provided for you. And then once we're done all of that, then we can describe any changes to the domain, range, the x and y intercepts, and our horizontal asymptotes. Okay? So if you guys want to, if you guys are feeling totally confident, you guys know how to graph these. We did lots of practice last section. We've done lots of practice graphing in general throughout this whole course and last course. So if you guys want to, you guys can use your graphing technology and compare the graphs that way. But it also is some good practice here to do it by hand as well. So our first one here, we have y is equal to 2 to the power of x. We can create those table values, so we have x and y. So we're going to stick with our nice easy values. We have -2, -1, 0, 1, and 2. Putting those values in, you guys can use your table values, or I will quickly run through the steps. So we'll have 2 to the -2. That's equal to 1 over 4. 2 to the -1. That is 1 over 2. 2 to the 0 is equal to 1. Remember, anything to the power of 0 is 1. Then we have 2 to the 1 is equal to 2. And 2 squared is equal to 4. So hopefully you guys remember how these negatives affect it. So the negatives will flip those values, and then you square it or apply whatever exponent is up there in that power there. Okay? So then let's graph this. So we're going to set this out as spacing here for your x is going to be every 2 ticks will be space. 1, 2, 3, and 4. -1, -2, -3, and -4. And then same thing with our y values. We can, every 2 tick marks can be 1 unit or 1 space. Okay. Alright, so then let's start graphing this. So we have at -2, when x is equal to -2, we have y is equal to 1/4. Approximately be right there. Sure. And we have -1 is equal to 1/2. Then we're at 0 is equal to 1. And remember, we didn't apply any transformations to this, so in theory, this should be 0 and 1. If it's not, we might need to go back and do some redo some calculations. Because remember, if we don't apply transformations, that y-intercept will always be at 0 and 1. Then we have 1, and y is at 2. Then we have 2, and y is at 4. Then we can connect our dots. Go back to elementary school. Connected. Apparently I need to go back. Connect those dots. Yikes. They look kind of roughly like that. Oh boy, I need to not have a squiggly hand. Alright, so that there is y is equal to 2 to the power of x. So we're going to draw all of these onto the same graph. So it's going to be very important that we label everything, okay? So I'm going to use a different color here, and we're going to start and graph y is equal to 2 to the x minus 1. Alright, and if we want to talk about that, this here is your h value. So here h is equal to 1. And so that means that we're going to have a shift 1 unit to the right. Okay, so if you wanted to, you guys could shift it 1 unit to the right, or if you wanted to double check this, you guys can make your table values. We have x and y. So actually what I'm going to do, ladies, is I'm going to quickly pause this video, I'm going to stop the video. We're going to start into video number 2 to finish this question, okay?